Hello, and welcome to this calculus lesson. This is the end of the section on continuity. This is video 5 of 6. And in this one, we just point out the limits in continuity of composite functions. So, for composite function, and this will be important to know later when we do the chain rule, you have one function inside of another. And in this case, you see there's an x squared minus 11. That itself could be a function, but it's inside of a square root. So this is what we call a composite function, as in it's composed of more than one function. So I'm going to erase that so we won't get confused. And I'll pick up this pen. So what this is saying up here, and I have managed to cut this off somehow, I'm not sure how I've cut that off, but is this was saying, in your notes you should see this, this is the same as f of the, well, you see what you need to see there. You can evaluate the limit of the inner function and then just put that into the outer function. And that's what I'm going to do. So first I'm going to find the limit as x goes to 6 of x squared minus 11. When I'm done with this, you're going to say, well, why did we make a video about this? I'm making this because several of you asked for it, but it is somewhat intuitive. You start at the inside and work your way out. So this function is continuous. So I'm good. I can just plug in the 6 as if it were asking me for the function value at 6, and I get 25. Now I've taken care of the limit and I've taken care of the x squared minus 11. I just have to do the square root of 25. I've found, so basically what it's saying is I can do the limit as x goes to 6 of x squared minus 11. I've never had a student really be confused by this, to be honest with you. They just, yeah, you find the limit and then take the square root. That you can do that. That was almost intuitively what you'd want, and the answer should be 5. Now, if your limit of the inner function did not exist, your answer would be did not exist. If your answer were infinity, your answer would square root of infinity would be infinity. Let's take a look at B, trig functions. We're not having as much fun with trig functions as we should be. Trig functions are fun. You should believe me on that one. So I'm going to, just like evaluating a function, first of all, does sine have a value? Is pi in the domain of sine? It most certainly is. If you remember, your sine function starts at 0, goes up, down, and back here like that, and this would be 2 pi. It's just sine of x, so there's no horizontal shift involved. There's no phase shift involved. This will be at pi, and this is a graph of sine of x, where this goes to 1 and this goes to -1. A little bit of a trig review there. So I can see if I do the tangent of the limit as x goes to pi of sine of x, I get the tangent of, and if I look at my graph here, and I should know this from my unit circle from pre-calc, and the fact that in my unit circle, pi is on the negative x-axis, and any point on the x-axis has 0 as its y-coordinate, and sine goes with the y-coordinate on the unit circle. So if y is 0, sine is 0. So the sine of pi is 0. So now I am asked to find the tangent. So the sine of pi equals 0. I'll write that down. I'm asked to find the tangent of 0. Tangent is sine over cosine. 0 radians is over here on the positive x-axis. Sine is 0. And if I'm on the unit circle, that point has a length of 1, so 0, 1. So this is 0 over 1, or 0. So my answer is 0. That is not the most complicated thing we've done in this unit. It's just pointing out that your function can be composed of multiple functions, and you just start at the inside and work your way out, just as if you were evaluating a function. Okay, so that's it for today's lesson on evaluating limits, and tune in for part 6.